Alright, so everyone, good afternoon. Our aim for today is how do we solve vector application problems. So again, we're going to use a lot of the notation that we saw yesterday. But for you to do now is just to copy down this definition right here. It's known as a bearing, which is something that you're going to see a lot of in the worksheet today as well as the homework for this lesson. Okay. But yeah, with that being said, can someone read the text here?
In navigation, a direction is often given a bearing, that is, as an acute angle measured from due north or due south. The bearing north 30 degrees east, for example, indicates a direction that points 30 degrees to the east of due north.
All right, thank you for that. So yeah, there's just a convention that is used in navigation, and the word problems that we're gonna look at today involve vehicles like airplanes and boats, right? So uh, the question, what the word problems would give directions in terms of bearings. But all you really need to know is this convention here. So like we start north. If it's north 30 degrees east, then you do north, right? That's 90 degrees technically. And then 30 degrees east, you rotate 30 degrees in the eastward direction. However, you still need to note the reference angle. So the reference angle here is 60 degrees, which is what we're going to use. Okay, so again, the angle being used here in the problem is going to be 60 degrees. It's still going to be the reference angle. And I know this is like very roundabout, but yeah, there's just the convention here that we have to be aware of. Okay. But yeah, with that in mind, does anyone still need the definition here? Anyone still copying it down? Right. Not. I'll move on and go to the worksheet. Okay, so the worksheet, again, I mean the classwork, which I uploaded on Google Classroom. But let me go through the first part of the question, number one. Okay, so it says an airplane heads due north at 280 miles per hour. It experiences a 38 mile per hour crosswind flowing in the direction north 60 degrees east. Okay, so there's an example of another bearing. Part A, express the velocity v of the airplane relative to the air, which in other words not affected by the wind, and the velocity u of the wind, both in component form, which we saw yesterday, right, in terms of I and j. Leave answer in exact form. So by that, they mean like leave as a radical, if there's a radical. All right, for the velocity of the airplane, it's going to be 280j, right, because it says it heads due north. Okay, so due north is directly up, so vertical. So it's going to be 280j. Technically, it's 0i plus 280j, but you can just write it as 280j. And this is, relative to the air, not affected by the wind, as they say here. Okay. The next vector that we have to examine is the crosswind. So that's 38 miles per hour in terms of the magnitude, which I write here. So magnitude u equals 38, right? That's 38 miles per hour. And then north 60 degrees east translates to a reference angle of 30 degrees. Okay, so let me draw that out. So we start north, right? That's convention, and then we go 6 degrees in the eastward direction. So that would be like here. However, that would make the reference angle will be 30 degrees. Okay, so reference angle is 30 degrees or pi over 6. Therefore, the vector can be written as 38 cosine pi over 6 I plus 38 sine pi over 6 j. Cosine pi over 6 is root 3 over 2. Sine pi over 6 is 1/2. We're going to end up with 19 root 3 I plus 19j. Okay, so here's your second answer. So yeah, again, we have to find the crosswind vector as well as the airplane vector, which is this one, right? So these are the two answers, 280j and 19 root 3 I plus 19j. All right. So yeah, just make sure you have this in your notes. And then afterwards, we'll move on to the rest of the worksheet. If you're finished copying this, you can go on to the worksheet, which we'll work on parts B and C of the classwork. All right. Is anyone still copying this? Okay, I'm gonna move on then. So yeah, again, the next part is, so I want you to just work on parts B and C of question 1. And I'm displaying it here, but again, it's also on Google Classroom. Okay. So take the next, let's say 4 minutes. So 1:38, we'll reconvene. So try your hand at parts B and C of question 1. Oh, whoops. That's right. Okay. If you're stuck, part B, so by true velocity, they mean, velocity affected by the wind. What that means is you're going to add the two vectors that we found in part A. So just combine them, right, add them. And yeah, you're going to get another something I plus something J vector. And then for part C, find the true speed magnitude. That's, square root of A squared plus B squared, using A and B from part B. And then the direction, use tan theta equals B over A. Okay, so see if that helps. All right, so let me pause you here. Let me go through the solution. Okay. All right, so again, as a reminder, these are the two vectors we got from part A, right? 280j and then 19 root 3I plus 19j. For part B, the true velocity, again, we just sum u and v. All right, so you just add these vectors here. For the horizontal component, it's going to be just 19 root 3 because for the airplane, there's no horizontal component. It's just 0I, right? So it's going to be 19 root 3I. And then for the vertical component, it's going to be 280 plus 19, which is 299j. Okay, so this is your final answer for part B. Okay, that's all it is. For part C, finding the true speed and magnitude, or true speed, which is the magnitude, and the direction, which means the angle of the airplane. We're going to use, square root of A squared plus B squared, referring to A and B here, right? 19 root 3 squared plus 299 squared. Square root of that is going to be 300.8 miles per hour, right? And then for the angle, it's going to be tan theta equals B over A, so 299 divided by 19 root 3. For that, you're going to have to use your calculator. So use arctan of 299 over 19 root 3. Make sure your calculator is in degrees. You're going to get 83.7 degrees. If you want to write that as a bearing, that would be like so. So like 83.7, that's like this angle right here. And then the bearing would be relative to the northward direction, right? So that would be this angle, which is let me draw that more curved. Yeah, 6.3 degrees. Okay, so that's 90 degrees. So this 6.3 is 90 degrees minus 83.7. So north, 6.3 degrees east. Okay. All right, I'll give you a sec to copy that down, and then from there I'll move on to question 2. Okay, anyone still copying this? All right, move on then to question 2. So question 2 is another situation with, and this time it's going to be a boat. Let me just erase the marking here. Okay. All right, question 2. Can someone read the problem here?
A woman launches a boat from one shore of a straight river and wants to land at a point directly on the opposite shore. If the speed of the boat in still water is 16 miles per hour and the river is flowing east at a rate of 8 miles per hour, in what direction should she head in the boat in order to arrive at the desired landing spot?
All right, thank you for that. So, all right, let me just write the solution here. Yeah, so this is a problem that you're going to see on the homework, right? It's going to be a very similar situation with a boat, and then as you're going to see, we're going to find the angle. That's what we're trying to find. Okay, so just like the first classwork question, we have two vectors here. The first vector is the speed of the boat in still water. That's 16 miles per hour. That's the magnitude. And then the angle is what we don't know, right? That's what we're trying to solve for. So it says, in what direction should she head the boat in order to arrive at the desired landing point? That implies that the angle is, unknown. We're trying to solve for that. So yeah, we create two vectors. We're going to add them together to create vector w, and then from there we'll solve. Okay, so the boat is, can be represented as magnitude v cosine theta I plus magnitude v sine theta j. Okay, so magnitude v is what we know. It's 16 miles per hour, right? As you see here. The angle we don't know, right? It's cosine, just leave it as theta, cosine theta I plus 16 sine theta j. For the river, it's flowing east at the rate of 8 miles per hour. So east is horizontal, right? So that can be written as 8I plus 0j. Okay, so I know that might be new, like it's a interpretation of these words, but like, yeah, it's just flowing east means it's 8I plus 0j, right? 8 miles per hour. Okay. All right, from there, the true course of the boat, right? So by true course, meaning like the boat moving and then also being affected by the river, the current of the river. You're going to add the two vectors together. You're going to get 16 cosine theta plus 8, right? That's the horizontal component, parentheses I, plus 16 sine theta plus 0j. Now here's the crux of the problem. Okay, so it says she wants to land directly across at the point directly on the opposite shore. So like she's going straight, like 90 degrees, right? In other words. Now, how to translate that mathematically is we're going to set the horizontal component to 0. Okay, so 16 cosine theta plus 8 equals 0. And then from there we can solve, right? I also leave an explanation here, right? So since she wants to land at a point directly across the river, the boat's true course should have horizontal component 0. In other words, she should choose theta so that 16 cosine theta plus 8 is 0. Okay, so that's the crux of the problem. Um, and yeah, this is just like reading into the question, but yeah, this is another I guess pattern pattern you're gonna see on the homework tonight. Okay. So after setting equal to 0, you can solve for cosine theta, right? Cosine theta is negative 1/2. And then the angle, the reference angle is going to be 60 degrees, but since it's negative, it's going to be quadrants 2 and 3, right? So let me draw that out. That's going to be located right here or located here. Right? But as we can see from the diagram, it's going to be, quadrant 2, right? We're going north. So it's going to be 120 degrees, and then as a bearing, this is going to be north 30 degrees west. Okay, so we start north, that's 90 degrees, and then we head 30 degrees west. So this is 30 degrees. And yeah, that'll give us the bearing measure for the angle. Okay. But yeah, let me know if you have any questions. I know this problem can be confusing, right? There's a lot of things we have to like pull from the word problem, right? The question itself. One of them being like 8i, right? That has to be dissected from these words. And then 16 cosine theta plus 8 equals 0. Right? That's another thing we have to translate from the given information. All right, is anyone still copying this? Or anyone have questions about question 2? There's one more question on the worksheet. Yeah, just let me know when you're done copying. All right, anyone else still need this? Okay, I'm going to move on then to question 3. All right, question 3. Here we have, well, actually, could I have another volunteer to read this?
Two forces, F1 and F2, with magnitudes 6 and 24 pounds respectively, act on an object at a point P. Find the resultant force acting at P as a vector expressed in terms of I and J. Leave the answer in exact form.
All right, thank you for that. So by resultant, they mean the sum of vectors. So that's a vocab word you might know from physics. If not, just know that you have to combine them, you have to add them together. Okay. First thing we're going to do is just dissect F1 into the horizontal and vertical components. It's going to be, so F1 has a magnitude of 6, right? And the angle, as you see from this diagram, is 45 degrees. So 6 cosine 45 degrees I plus 6 sine 45 degrees J. Cosine 45 is root 2 over 2. Same thing for sine 45. So it's going to be 3 root 2i plus 3 root 2j. For F2, the magnitude is 24. So, its magnitude would be cosine theta plus I, right? Sorry, cosine theta I plus magnitude v sine theta j, right? So magnitude here is 24. Angle is 150 degrees. So I know this isn't quadrant 1 technically, as you see from this diagram, but we have to refer to the direction. So it's facing west, right? It's facing that way. So the angle that we're going to use is 150 degrees. Again, I know this is confusing since you see the XY axis here. So it's in technically in quadrant 1 where it's located, but again we have to note the direction that it's facing, which is left. Okay. All right, so that's why we're going to use 150 degrees. Cosine 150 degrees, that's negative, right? Quadrant 2 cosine faces left, that's negative. That'll be negative root 3 over 2, so it's negative 12 over 3i. Then sine 150, that's going to be 1/2. Okay, still positive. So it's going to end up being negative 12 over 3i plus 12j. And then for the resultant vector, you just add them, right? So you get 3 root 2 minus 12 over 3 parentheses i. And then for the vertical component, you get 3 root 2 plus 12 parentheses j. That's your final answer. All right. While you finish copying, let me close with announcements. One, there's SGI today, per usual, 247. Secondly, as I said yesterday, our next quiz will be next Thursday because, there's no school next Friday. So I'll send the topics list over the weekend, most likely on Saturday. And I'll see what I can do about a practice quiz on ALEKS. If there are enough, questions on ALEKS, then I'll set that up. If not, then we'll just have to do the quiz by itself. Okay. All right. But yeah, if you have no further questions, you're free to go, and I'll see you on Monday. All right. Have a good weekend.
Thank you. Have a good weekend.
Thank you.
Yeah.
All right. You're welcome. You too. Bye.